Hello everyone, this side Saurabh, and today we are going to discuss the problem number D of Codeforces around 1103, that division 3 problem. And this is problem number D, that is brand new Tatар TV show. So let's first understand the problem. So let me explain you the problem. So in this problem we have given an array and an integer k. Okay, suppose like this. So in this problem we have given an array and an integer k, and array will look like something like this: 3 3 3 3 3, and suppose here k is 1. So we have given this array, and there are 3 persons. One is Dabir, other one is Egor, and the third one is Arseniy. Okay, so these are the 3 persons who are going to play the game with this array and k. So now the game is each time. Now the game is between this Dabir and Egor, and Arseniy is the guest. Okay, the game is between Egor and the Dabir. And what is the game? In the game, suppose there is a turn of Dabir, then Dabir will choose an element from the array, and that element will vanish from the array. And then turn goes to the other person, then other person again take the array, any element from the array, and vanish that element from the array. So at the end, if the person who is not able to choose any element from the array, then he will lose. Okay, so suppose this is the array that is 3 3 3 5 times, and the first move is goes to whom? The first move is played by Dabir. Okay, first move is played by Dabir. Now what happens is, suppose Dabir chooses. Now in the first move, Dabir choose any element. Then next element. Then there is a condition between choosing the next element that depends on the first element. Suppose Dabir chooses the element something like x. Okay, now the turn goes to Egor. Now if Egor choose an element y, then there is a condition. What is the condition? The condition is that this y should be greater than or equal to x. This y should be greater than or equal to x, and less than equal to k plus x. So this is the condition given to us, that the chosen element, that the next element that is going to be chosen must be greater than or equal to the previous element chosen, and less than equal to k plus x. And this k is given to us already in the question, like here k is 1. And for the first move, there is no constant, we can choose any element in the first move, but the next move is condition. Take condition, this is the condition we have to follow. I hope the question is clear. The first move is taken by the Dabir, and at first we can choose any element from the array, but the next move must follow this condition. That means the next element must be greater than or equal to previous element, and less than or equal to k plus previous element. So this is the game, but there now a twist. The twist is, there comes this third guest, that is the Arseniy. Now Arseniy comes as a guest. Okay, so as a guest, these two people given the chance Arseniy to move first. That means the first element will not choose Dabir. Dabir will not choose the first element. In place of Dabir, the Arseniy is going to choose the first element. Okay, and the Arseniy and this Arseniy comes out to be a friend of Arseniy is the friend of Egor that the beat not know. Okay, first move is done by Dabir, but now Arseniy will choose the first move, but Arseniy is the friend of Egor. Now our responsibility is to determine that whether we can make any sequence that led the win of Egor. Okay. Question is, can we make any sequence of play that finalize the win of Egor? And we have to return yes or no, that is whether it is possible or not. Now let me summarize everything. There is an array and is a key. First element now chosen by Arseniy, that is a friend of Egor. Now before Arseniy, the match will go like this: Dabir, Egor, Dabir, Egor, Dabir, Egor. But now the match will be like first Arseniy, then again Egor, then Dabir, Egor, Dabir, Egor. First Arseniy, Egor, Dabir, Egor, Dabir, Egor. Now the first move will be done by Arseniy, and Arseniy is a friend of Egor. That means that the first two move is in our hand, and in the first two move we have to decide a sequence that will guarantee the win of Egor, and we have to think that it is possible or not, and based on that return the answer. So let's discuss some test cases to understand the problem in much better way. So let's discuss some test cases. So we are going to discuss the first test case in which the array is 3 3 3 3 3. Okay, and the key is given as 1. Now first move, now we have to choose that whether it is possible to make Egor win or not. First move will be by Arseniy. Okay, first move by Arseniy, then again Egor, then Dabir, Egor, Dabir, Egor. Now Egor, I think it's Egor, not Egor. Now first move done by Arseniy. Suppose Arseniy chooses the first element. Now the game starts. Now the game starts. Now first element is chosen by, now it's Arseniy turn. Arseniy chooses the first element, that is 3. Now the second moves come. According to condition, we have to choose the second element that must be greater than or equal to previous element and k plus x. That means now the next element should be greater than or equal to 3 and less than or equal to 4. So as we can see, we can choose any element except the first element that we have to choose from this. Now Egor comes, it will choose the second element. Then the Dabir comes, third element, then Egor, then the Dabir. Now the chance of Egor comes and there is no element in the array. So in this test case, the Egor lose. So we can't guarantee that if the Dabir plays optimally, the Egor will win. That means in the first test case, it is not possible to guarantee that Dabir will win. Okay, not Dabir, Egor. Let's discuss the second test case. Second test case is like 1 1 2. 1, the array is 1 1 and 2 and the key is 1. Now there is the turn of Arseniy comes. The first two move is in our hand, and we have to ensure that we will win. Now let's consider we are Egor, and we have to win. So each even move is ours, and each odd moves are of our opponent. Okay, but the very first move is in our hand also. So we have to think. Suppose if we choose this, if in our first move, as the first move is in our hand, okay, so in the first move if we choose the element 2, suppose we choose this element 2 in the first move, so now our terms comes in the second as odd even term, our terms comes, and we have to choose an element that is greater than equal to 2, and here there is no element that is greater than equal to 2, then we will lose. So I think we should not play like this. And what if we choose in the first move this element 1, and in the second move we choose element this 1 and this 2. Let me discuss the whole possibilities we can do. Okay, so in the first move there is one possibility, that is, let's discuss possibilities. Okay, so possibility 1, if this is the array, let's keep in mind that each even term is our, each odd term except the very first one is our opponent, and we have to play in this way that we have to win. Okay, so the first possibility that we can start with the first element that is chosen by 1, then our terms comes, we can choose again 1, then our opponent comes and we will choose the 2. One possibility goes like this. Other possibility, we can choose the first element as this, then our terms come which is the second element as this 2. Third possibility, we choose the 2, then there is no turn available in the next move. So these are the 3 possibilities we can choose. Okay, so in the first possibility we lose, in the second we win, in the third we lose. Okay, so we can deduce that if the sequence is odd, then we lose, and if the sequence is even of the game, then we will win. Okay, so these are the 2 deductions we have made, that if the sequence is odd we will lose, and the sequence is even then we will win. So we have to choose the element according to this condition, and each even move is ours, and each odd moves except the very first one is our opponent, and we have to choose the elements according this condition. I hope now the problem is clear. Now this time we have to think about the solution. How can we solve it, or check if any array is given and any k is given, and we have to make a solution that will tell us that whether it is possible that we can guarantee or not. So what comes in my mind is, so there is suppose some elements in the array and there is a k, so we can start with any of the element given in the array. So the game can be started with the first element, second element, third element, fourth element, or the fifth element. So there are many ways to start the game. So if we start the game, then the next move depends on this k. So I can see that there is a different sets we can make the elements that is based on our first element. So there can be different sets we can make where we can go based on the first element chosen. Suppose there is an example, if I take suppose 1 5 1, 5 and 1, and k is given as 1. Okay, if this is the condition or situation. So if we start with any 1, then we can go like this, and if we start with 5, we can visit only these two elements, none other than this. Okay, and so there comes the two sets based on the first element we have chosen. Okay, suppose there is another example. Suppose there is 1, 2, 3. Okay, then 5, 6, 7. Okay, and there is something like 10, and if k is given as 1, so if we start with the 1, so if we start with 1, we can go only 1, 2, 3, none other than that. We can only go 1, 2, 3. Okay, and if we start with 5, we can go with 5, 6, 7, and if we start with 10, then we can only visit 10. What if we start with 2, then we will only visit 2 and 3. But we can separate the elements based on the first element, the smallest one, where we can go. If I choose the first element like that. So let's discuss another test case. And in another test case, suppose the element is like this: 2, 1, 3. Okay, and there is 5, 4, 6, and there is something like 9, 13, 99 and 11, and the k is given as 1. Okay, now we have to think that is there any sequence we can make which led to our guarantee to win, and if the length of the sequence is even, then we will win. So we can derive the maximum length of sequences we can go if we start from particular positions, and that will cover the whole array. So I can see that we can travel these 3 elements at whole if we start with the 1, and I can travel this whole set, this maximum set, if we start with 4, and in this one 99 and 11. So our first goal is like separate the elements in the sets with maximum length that can be visited at once, at one possibility. Okay, so our first goal to separate the elements in the sets with maximum length that can be visited at one possibility. So how can we separate the element that will make sure that we can get the maximum length of each separation or each game that can end by choosing the starting point? So what we can do, we can just sort the given array. When we sort this, when we will get like this: 1, 2, 3, 5, 6, 7, 9, then 11, 1, 2, 3. Suppose there is not 6, there is 7, 11 and 99. Now this will help us to find the maximum length we can go if we start with any win. So what we can do, we can very simply from here separate in the sets, these sets like this. Like these are the sets where we can go with maximum length if we start with the minimum point. Okay, so why we are choosing the maximum length? The idea behind is our goal is to make the length as even length to make sure our win. So if the length is maximum, where we can visit is from starting from the very small point, so we can anyhow make the length even. Okay, so these are the things. Now our first goal is done. We can make our each possibility in one set, and second move is like we can take each subarray and discuss and check whether it is possible to guarantee that any sequence here exists that led us to the even length of place or sequence. So suppose if we take 1 2 3, so where first we check this 1 2 3. Now we can start with 1, we can start with 2, we can start with 3. Okay, what if we start with 3, with k is 1, then the length, then we can't go further and the length will be odd and we lose. But what if we start with 2, then the first two moves will in our hand and the third move cannot be done, and this will our opponent will lose. So if we start with 2 we will win, if we start with 3 we will lose, and also if we start with 1 we will lose. Okay, in the same idea, this 5 6 7, if we start with 7 we will lose, but if we start with 6 we will win, and if we start with 5 we will lose, and as same in this 11 and 99 we will lose. So we have to think how can we win in any particular sequence. Now we have the sequence where we can visit all elements if we start with one point, that is the smallest point. Okay, now what? 1 2 3 5 6 7 done. Suppose if any sequence is given, how we decide we will win? We will win if we make a sequence under that of length even, then we will win only. Okay, so if this 1 2 3 is given, so if we see from the maximum element, if we anyhow make 2 elements, then we will always win. So I can see we are winning in each situation if the length is, if at least we get the length as 2, we will win. So here we deduce one thing, that so if the first thing, the thing we have observed, that if we get any sequence with minimum length 2, we will win. As simple as that. So if we get any sequence with minimum length 2, we will win. Okay, so anyhow if we get 2 elements that is not equal, we will win. Suppose in the last, any sequence in the last, if you saw something found like 4 and 5, then we just simply start our move from 4 and then go to 5 and we will win. Okay, but the problem arrives if the last 2 elements are equal, then there is a problem. Then we can go one step back also if there is the length. Okay, so in this case we can just simply check that next element, if the previous element is also equal or not equal, then we have to check that. So if you are equal, then we can check for the next other element, and if you are not equal, then we will lose here. Okay, so if you lose, then we have to check for other also. So if we think properly, we can make a deduction like when we lose, we only lose in a situation if the all elements in the array where we can go is equal and the length is odd. So when we lose, so there is only one possibility. When we lose, we only lose if all the elements in the subsequence where we have traveled is when all elements of sequence is equal and the length is odd. So these are the two possibilities where we can only lose, and if this is not the case, we always win. Suppose we will lose only here, that the all element is equal and the length is odd, but if we anyhow get any other element like 2, 3, 3, if any single element is not equal, then we always win. Like we can start from 3 and we will win. There is only a way where we will win. Okay, now we can check this with other examples, like suppose there is a element 1, 4, 6 where we can go, so we can start here 4 and just win. There is only one possibility where we can lose, that all elements are equal and the length is odd. So let us try to code this out. Okay, and the things will be more clear while I code. Okay, so this is the problem, and each input test case is multiple test cases. First line please. So let's code it out. Comment and now let's try to code this. So first we include our libraries, bits std c++ package, then namespace, then main function, and we are going to return 0. Then there will be a test cases. We take the input, and for all test case we will solve. Okay, don't worry, things will more clear by the code. So this is function. So in each function we have n and k as given. So there is n, there is k. Take the length input and take this k. Okay, and in that there is integers, then we can make our array of size n and just take the input. Okay, now we have given an array, and what is our first move? Our first move is to sort the array. Okay, so sort the array to make the sets that can be visited anyhow at once in one game. Okay, so we have sorted the array. Now we can make a vector of integer to store these sets. We can call them as sets, and we can take a temporary vector to store them. Now we can just traverse in this array, give an array. So if we can just simply put the first element first, then without push back this first element. Now if we are checking with the next element, so now go to last. So if my current element is equal to this, or current element, and we can start with the first element. Start with the first element, go till the last element, and check whether this element is able to come up with us or not. That means whether this element is greater than equal to previous element. What is the meaning of previous element? Until when we will push. Okay. So if this current element and the previous element differences become greater than k, then only what we do, sets dot push back this stem and make this stem as an empty, or again start with this stem. This current element. So this is just logic to separate the elements where we can visit according to condition. If you are not list, then just simply push yourself in the temp. Now the sets include the set where we can go at once in a game if we start with the minimum element in that particular set. Now our goal is to now traverse in these sets and check whether each sequence in any sequence we can guarantee that we will win or not. If this check returns true, we will see out like what else we can and just handle and break out. And if no one is able to make guarantees that we will win, then at last, not break, we will just simply return. If that's not the case, we will print the no, do and just return. Not need to return, it automatically return. Now this time is to check function that any sequence where we can totally visit is able to possible or not. Okay. So this is the boolean check that takes an array, and how we have ensured that we will lose. There is only one condition and all elements are equal, and the length of the array is what? Odd. So we can just simply take a counter 1 and check in the array till -1. So if array of I is equal to array of I plus 1, then just make it count plus that this is the length and every element is equal. And if any time we get that there is an element we found that is not equal, that means we can make this guarantee. And at last, if our count is equal to array dot size and this count modulo 2 is not equal to 0, that means the odd, then only we will return false, that we will lose. None other than we will return here true. Now we can not check here this else, just count plus if you are equal, now we need to. So this way we can solve the problem. Now let's just use test cases. Let's run this code, and here we go the output. What is the output? Output is not coming. So here we got output like this. I think we have made some mistakes. Where can be the mistake? I think we forgot this last assignment we forgot. Now let's test it out again. So we get no 4s, no s. No 4s, no 4s, no s. So this way we have solved the problem. Let's meet in another problem. Goodbye.